Hi Science friends, today we are going to talk about exceptions to the octet rule. So we've talked a lot about the octet rule. That's what we've always prioritized when we've drawn these list structures, trying to get 8 electrons on everything except hydrogen. But there are some cases where you don't have the octet rule filled. And so here's the cases that you don't have the octet filled. So the first one, the central atom has less than 8 electrons. It's said to be electron deficient or an incomplete octet. That's what your worksheet today is what we're working on. We're looking at incomplete octets and expanded octets. So incomplete is when they're going to have too few electrons. Expanded is when they're going to have extra electrons. And so here's a few elements that you frequently see that happen with beryllium, boron, and aluminum. You will see often have fewer electrons. You can also have compounds that have an odd number of valence electrons. You see that a lot on nitrogen, specifically compounds that only have 1 nitrogen in them. So nitrogen has 5 valence electrons, and so sometimes when you have, if you had nitrogen with oxygen, for example. Oxygen has 6, nitrogen has 5, so that's going to make 11. So you can't have a pair with 11, right? Something is going to be unequal. And so sometimes you'll have an odd number of valence electrons. And then the last one is the other one I just mentioned ago, our expanded octet. And that's when you have more than 8 electrons is the expanded octet. And so these are only going to be in elements in period 3 and higher. So you're not going to see them in your carbons and oxygens and nitrogens, only in elements in period 3 or higher. Okay? Now, this is important. Carbon, nitrogen, and oxygen and fluorine always obey the octet rule, except as I mentioned, sometimes nitrogen is going to get hung up here a little bit, but they are going to try to satisfy the octet rule first, okay? So we want to try to fill them first, and then if we have extra electrons, then we're going to put them on elements that are in period 3 or higher, and typically it's going to be the center element, okay? So I know that's a lot of rules, and that's kind of hard to, figure out what we're doing here, but I think it'll make sense as I show you some examples. So let's look at a few examples here together. I'm trying to pull up a periodic table so that I can have that convenient. So AlCl3. So we first need to add up how many valence electrons that we have. That's what you're doing in step 1 today, is just writing how many valence electrons that you have. So aluminum has 3 and chlorine has 3, but has 7, but you have 3 chlorines. So that's going to be 21 plus this 3. We've got 24 total valence electrons that we're going to deal with, okay? Now, because we just have 1 aluminum, we are probably going to make that our central atom, okay? And so let's fill in with chlorines all the way around. And then let's try to complete the octets of the chlorines as best we can. Okay, so the way that we've done it so far, we have 24 electrons, and that looks pretty good. This is, though, considered to be an incomplete octet because, it's deficient in electrons because aluminum, if you count the electrons on aluminum, only has 6. So all of the chlorines are happy, but the aluminum is not very happy. Okay, now you may ask, why did we fill up the chlorines first before the aluminums? Well, chlorine is more electronegative than aluminum. Remember, the most electronegative element on the periodic table is fluorine. So electronegativity increases as we move up and to the right. And so chlorine is going to be more electronegative. So if there's any electrons to steal, chlorine's going to have them, and aluminum is going to be left deficient. Okay? Let's look at another one together. BeCl2. So Be is in group 2, so it's got 2 valence electrons, and then 7 again for chlorine. So that's going to be 14 plus 2 is 16 valence electrons, okay? And then, sorry, just to come back up here, in the step 3, you would just draw it with the bonds like that we have been, and then fill your dots all the way around. My dots are kind of hard to see there, okay? But that's how you would do step 1 on your assignment, step 2 on your assignment, step 3 on your assignment, okay? Let's go back to BeCl2, beryllium dichloride, or actually just beryllium chloride. It's not di because it's a ionic bond. So 16 valence electrons. So we're going to put our beryllium in the middle, and we'll bond with a chlorine on either side. Now, if you chose to bond on top and bottom, that's okay. Or if you even did top and side, that's still okay too. And then we're going to fill up our chlorine first. And that's got us with 2, 4, 6, 8, 10, 12, 14, 16, the correct number of valence electrons. But again, this is an example of an incomplete octet. Chlorine is complete, both chlorines are, but beryllium is lacking. It only has 4 valence electrons instead of the 8 that it usually hopes to have, okay? And so when we draw this, I think you know how to draw these pretty good by now. It would look like that, okay? Let's look at one more with boron trifluoride, okay? Boron trifluoride. So boron is going to have 3, and then fluorine is going to have 7 times 3, so that's 21, and then plus 3 is 24, okay? So it's going to look pretty similar to the first one that we just did. Our boron's going to be in the middle. Our fluorines are going to be all the way around. And that takes care of our 24 valence electrons. Again, this is one that's incomplete because it's lacking these valence electrons here. Okay, and you would draw it just the same way over here. Now, I'm actually going to do these with you instead of let them be you try it problems because these are just a little bit different. Specifically, I think that for sure the bottom one. So this one is iodine trichloride. So iodine and chlorine are both in group 7. So we're going to have 7 times 4 or 28 valence electrons here. Okay, so let's put our I there. Put our chlorines all the way around. Okay, so what we have now, we have 8 plus 8 is 16, plus 8 more is 24, 25, 26. And that's going to complete the octet for everything. Everybody's got a full octet here. But we have to get 28 valence electrons. So what we're actually going to do is we're going to squeeze 2 more electrons onto iodine. It's going to have extra electrons. So this is an expanded octet, okay? So when we draw this over in step 3, you want to always kind of pair those, and usually they kind of try to write them like in the corners. That's typically how you see it done, like that, and then fill these in too. That is what this one looks like. So this is an example of an expanded octet, okay? And that gets our 28 valence electrons. Now let's look at the last one, SF6, okay? So sulfur has 6 valence electrons, fluorine has 7, times that 6 is going to be 42 plus 6 is 48 valence electrons, if I can count correctly. Okay, so sulfur. Now, we have never bonded anything with more than 4 electrons, or more than 4 elements, or atoms, but we are going to here. Sulfur is actually going to make 6 bonds with all of those fluorines. Sulfur is in period 3, so it can do that. And you just kind of got to squeeze them in there as best you can. Okay, sulfur is in period 3. So, and then we'll go ahead and try to fill the octets on all of the fluorines. Draw in all of these little dots. Make sure all of the fluorines have 8, so they're happy. Okay, so count with me. I have 8, 16, 24, 32, 40, and 48. 8 on each of those fluorines, all of them sharing with sulfur as well. And so that knocks out my 48 valence electrons. Again, this is an expanded octet. Okay, this is an expanded octet. I want to do one more that's not shown on here, but I think you've got some room on your paper that you could do it. But I want to do NO2, okay? And when we write this one, you would do the same thing. You would put your sulfurs all the way around, and then fill their octets with dots, okay? I think I got 6. Yep. Okay, let's try one last one, NO2. So NO2 is going to have nitrogen has 5 and oxygen has 6, and there's 2 of those. So that's 12 plus 5 is going to be 17 valence electrons, okay? So we're going to put nitrogen in the middle, and let's bond it, with an oxygen. Started to draw a double bond there, but I think I'm just going to draw a single bond. I may need to change it to a double bond later, okay? And let's try to fill the octets for oxygen and see what we come up with, how our numbers play out, okay? So that gives me 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. And if I put one more on here, that makes 17 valence electrons. And so nitrogen is deficient. Now, you might do it like that, but there's actually a way that you can do it that's better, okay? So let me show you the way that's better. And again, this is one of those trial and error things, okay? If you double bond one of the oxygens, 2, 4, 6, 8, 10, 12, 14, 16, 17, then everybody comes closer to achieving the octet, okay? In this diagram, oxygen has 8. This oxygen has 8. This nitrogen has 5, okay? 8, 5, 8. But in this diagram, oxygen has 8. Nitrogen has 7, and oxygen has 8. So this one is the preferred Lewis structure, or it's preferred, it's the correct, technically, Lewis structure, because you maximize the number of valence electrons on all of the elements, okay? Nitrogen still doesn't have a full octet. You're never going to get that when you have 17 valence electrons because it's an odd number. You're always going to have one side that just has 1. But it's closer here, sharing this pair with oxygen, it gets to 7, which is closer than 5 when you have all single bonds, okay? Also, remember, nitrogen likes to make a triple bond, or 3 bonds. And so this arrangement allows nitrogen to make the 3 bonds that it likes to do. Okay? So you will work on those today that I've assigned. There's not very many of them, so it should be a pretty quick assignment. But if you have questions, then of course reach out to me, and you'll have a great day.